Hello everyone. In the past couple of sessions, we have actually looked at what series objects are and what data frame objects are. We also have dealt with few of its key attributes as well as methods. And now in this session, we are going to look at how you perform indexing in data frames, how you slice a given data frame, how you extract specific rows, also subset the given data frame in terms of extracting specific columns as such. Later, we are also going to understand in detail on how you set a custom index to a given data frame, as well as setting a particular column as an index and resetting the already set column as an index. Okay. So let's begin our discussion by considering this particular dictionary called store dictionary. So within this particular dictionary, I have necessarily provided all of these key value pairs. So the first key value pair here is store ID and its respective values associated within a given list. And now we also have number of customers, number of items and location. So when we are trying to convert this particular dictionary to a data frame, all of these keys are now columns, and whatever values that are associated with every single key would become values specific to that particular column. Now let's consider this store dictionary. Use pd.dataframe and within parentheses provide this store dictionary. Let me assign this to store underscore df. Let's also inspect this particular data. So we clearly understand that every single key here is now a column within this particular data frame. The number of items is another column, location is again another column. So all the values pertinent to store ID are now the values associated with this particular column within the data frame that we have created. So we have learned that we can reference any given column by providing that column name within the subscript. Let's say that I'm looking at extracting this data specific to number of customers. I'm going to provide this number of customers column name within single quotes within this particular subscript notation so as to understand what are its different values as such. Okay. And how do you perform indexing here? So if I would want to extract only the first three observations, first three data points here, so obviously 0:3, we are using the integer based indexing. So these are different integers that are implicitly assigned while creating the data frame object itself. So we are making use of these values, these implicit indices in order to extract specific data points or observations here. So 0:3 is going to extract all the records starting from index 0 till 2. You know that the end index here is always excluded. So this is the end index and this is the start index. So all the records that start from start index till end index being excluded are now displayed here. If I'm not providing any end index at all, that essentially indicates that we want to display all the records starting from the start index. I can also provide start index as 4 so that all the records starting from index 4 is now displayed. I believe you have pretty much understood on how you perform indexing operations per given data frame. So instead of leaving a default indexing mechanism, we also can explicitly define an index here while creating the data frame itself. Now let me write a simple list comprehension that reads from this particular range object whose values are ranging from 65 to 65 plus 7, right? 65 to 72. And now I am going to make use of this particular I value, use that as an argument for this function called chr, which actually converts these respective ASCII values into characters. So now there are in total about 7 different items that are present within this list. I'm copying this complete list comprehension, using this as an index while creating the data frame itself. And now if you closely observe, all the implicit indices are now gone. Whatever explicit indices that now I have defined using this list comprehension are updated to the data frame. So instead of using integer based indexing, now you can make use of these labels that we have newly assigned. The key difference between integer based indexing and this label based indexing is that the end index, so we are not providing index, but rather we are providing labels. This end label is always included. So in case of integer based indexing or implicit indexing, this end index is always excluded. But here we are not providing index values as such, but rather we are providing labels or explicit indices. I'm calling them as explicit indices. When I say that it's explicit indices, then I mean to say that they are nothing but labels. So D is always included in the result here. You can further explore on not providing anything after this colon, so as to make sure if all the records from this starting label are printed out or not. If I'm giving it as D, then we clearly know that all the records starting from label D will be printed out now. So this is what we have learned so far. Even for series objects, this is how we have worked on indexing operations. We have essentially looked at selecting specific records here or specific rows here. We also have looked at how you extract specific columns here. So when I say specific columns, now I can basically go about providing an inner list within this subscript notation so as to look at deriving only specific columns like number of customers and number of items here. I'm ignoring all the others. So now you observe that there are only two different columns that are present in the resultant data frame. The remaining columns are now excluded. So this is how you look at subsetting the given data in terms of the different columns that you are trying to select here. Okay. Now we have understood in detail on how you perform explicit indexing, implicit indexing, as well as how you select specific columns from a given data frame. So instead of having explicit indexing like what we have defined here, we also can define a custom index using pd.index. Let me provide a range object within this particular parenthesis. Let me start from 10 till 17. I'm calling this as custom index now. If you look at the type of this particular object called custom index, it clearly states that this is an object specific to class range index. Okay. You can also print what custom index is. So this is a range index. The starting value is 10 and stop value is 17 and the step size is 1. The default step size is always 1, as you know. Now for storedf, if you reference this index attribute, we get the list of all the indices that are currently available for this data frame. Now I am assigning this custom index that I have newly defined. Once I update the index, now you can redisplay this particular storedf data frame. Now you understand all the labels that we have defined earlier as indices are now gone, but rather whatever we have defined as part of custom index are now displayed here. Okay. So I believe we have pretty much understood on what custom index is and how you can update existing index that we already had for storedf data frame. Now let's also look at creating a new column altogether called as item value. So item value, I'm just assigning np.nan so that all the values pertinent to this new column are updated with nan, completely missing out. Okay. Now let's try to look at providing or updating the item value for specific indices. Like let's say that I would want to update item value for this index 12, 14 as well as 16. Now I'm going to create a series object for that purpose. So pd.series is going to help me create this series object with the respective item values for the indices that I'm planning to update. All what I'm trying to achieve here is to update item value for specific indices that I'm planning to update for. Okay. So item value would be 89, 18 and 99, just providing some random values here. So I am now planning to look at updating indices 12, 14 as well as 16. Let me assign this to this existing column called as item value. Let me assign this series object back to this particular column reference. Also display this resultant data frame. Now you understand clearly that we were able to update this particular column with these values that I have explicitly stated, $89, $18 and $99 for these index positions. So index position 12 is now updated with $89. Index position 14 is now updated with $18 and index position 16 is now updated with $99. So this is how you can simply go about updating a given column for specific indices here. Okay. I believe we have dealt with most of the indexing operations that one can perform for a given data frame. And finally, we'll also have to learn about how you set a specific column as an index rather than explicitly stating what could be the indices. Let's say that store ID is one such column, which is always unique because every store is unique. There are no stores that can be replicas of itself in reality, right? So obviously every single store for a particular retail chain will actually have a unique store ID. So I simply can make sure that index for this given data frame can be store ID. So let me use this particular method called set_index And within this set index, within this parenthesis, I'm going to provide store ID here. I'm also reassigning this to the existing data frame called storedf as a whole. So now whatever change that I'm doing is in effect. So let's display storedf. And now you understand that store ID is no longer a column, but rather it's an index. In order to make sure that it's an index, you can always reference this particular attribute called index. You clearly understand that the index here is going to be store ID by looking at the name of this particular index. Name is given as store ID here. You also can reference what could be the columns now, and store ID is now removed from the list of columns because that's now being set as an index here. Storedf.columns is going to result in the list of columns where we are not observing store ID anymore. You can later look at resetting this index back by using this method called reset index. And then let's provide drop is equal to false so that the resultant index is not dropped out, but rather it's added as a column within the given data frame. We need to reassign this back to this existing data frame so that the change that we are doing is in effect now. So now we clearly understand that store ID is not dropped off completely from the data frame, and it's no longer index here, but rather it's being added as a new column to an existing data frame here. So that's how you can set an existing column as an index. Also reset an index which is already set here. Okay. I believe you have pretty much understood on the different indexing operations that one can perform on data frames. We also have looked at how you define a custom index. We also have understood the process in which you can update a particular column for a specific set of indices. And later we also have looked at understanding more about how you set a specific column as an index and how you reset already set column and without actually dropping it from the data frame by providing drop is equal to false as argument within this particular method here. Okay. So that's all I wanted to discuss with you in this session. Thanks for watching.